Let us now discuss about NLP. NLP here stands for Natural Language Processing. Natural Language Processing. The greatest difference between NLP and text mining, or of course, this is also part of text mining, but the sentiment analysis that we have discussed in the previous tutorial, right, wherein we have generated word cloud, the positive, negative word cloud, etc. There, we were only trying to extract the features, the positive words or the negative words. But in what context was it used? For example, if someone says, wow, iPhone has amazing battery life, right? And when you do a bigram, amazing battery would come up. So the moment you look at that, you might be thinking that, okay, someone is writing positively about the battery. But what if this person has continued saying that battery gets drained in just 1 hour? Now, you want something in line to natural language processing, which would actually process each and every word and then try to read this particular word in this context and let you know that this word amazing battery was used in a negative way, sarcastic way, right? So that is natural language processing. I can say that this is a touch above your text mining. We'll be discussing about LDA, right? LDA stands for latent directly allocation, basically, right? So I'm really not sure on how to pronounce that LDA, right? A few of them say it is Dirichlet, a few of them say it is Dirichlet, so on and so forth. Anyways, in short, we will anyways discuss about this LDA in the subsequent sessions. And then we will look into topic extraction using LDA. We will read the entire content and try to see on how we can extract the data. And this natural language processing can be done on various languages. It is not just confined to English. You can do that on Kannada, right? Telugu, Hindi, Chinese language, so on and so forth. However, Python is very good at text mining and web scraping and web crawling in comparison to R, right? And it's computationally very expensive. And if you have an 8 GB RAM, you might run into trouble, your R might crash, so on and so forth. But Python is going to deal with that situation of big data also and not crash. From big data perspective, Python is much better in comparison to R. Or you can have your server, which is of very high configuration, or you can use your cloud services, Amazon Web Services maybe. And how to deal with unstructured data and how to get some structured information from unstructured data. That is also another thing that we'll discuss about. We will discuss about sentiment extraction in a narrative. So say you have a novel. You need to look into the entire novel and explain about whether the trend is positive or negative, so on and so forth. And we have lexicons. Lexicons are parsers which are mostly open source. They are kind of your dictionaries. You can use them as dictionaries and you can extract a lot of meaningful information from that. So these are various things that we are going to look. We are also going to look at emotion arc curves, which will tell you about the emotions and all that. Suppose you have the story of a movie written, right? When you give that script as an input here to natural language processing, it will explain about this particular curve, which will say that initially there was a lot of positivity, then probably the actor died, so you went into the negative zone. The feelings, emotions were sad, and then later on towards the end, happy ending. So again, you came back to the positive spirit. In that way, we can look into a lot of emotion charts. We'll deal with all that. All right. What are the various places where NLP is used? Search engines, needless to say that. Google initially used to use query-based search, but slowly they moved to artificial intelligence, AI, and text analytics is a good start for AI basically, right? It is going to teach you the pattern in which people are searching the content. And one more best part about this is natural language processing is text mining on scale. That means when Google does this Google search, it is going to do that search on population, not sample. So your algorithm should be much fast, right? It's done on a population, hence it's on a scale. And your Bing uses neural network, Bing, Microsoft Bing. You can also use this natural language processing for spam detection. And of late recently, Google has claimed that they are now able to achieve 100% accuracy when it comes to spam detection. But a few of the firms such as LinkedIn are doing a pathetic job from spam detection perspective, right? So what it does is it's going to read the raw text, understands whether it is spam or not based on Bayesian classifiers, right? So we are going to discuss about this as part of a data mining tutorial. Yeah. And this Bayesian is based on your mixture model, Gaussian model or normal model, normal distribution. Okay, we'll touch upon all that later on. I'm just giving you a brief introduction now. It can also be used in your recommendation systems. Amazon uses to recommend a product, and it also uses the text analytics or your natural language processing. You can also use it for anomaly detection. Say you have a lot of narratives, you have Twitter hashtag product sentiment going on in Twitter. Say the sentiment is all the while positive on Twitter about a product. Suddenly it became negative, as in the case of Maggie incident. All the while it was super positive, right? Reviews about Maggie, the tweets about Maggie was super positive. Suddenly it became negative because someone has told that there is excess lead content, which is going to be, you very harmful to the human health. Now, how do we identify that? The moment there is a dip or there is some different pattern going on, you should be in a position to identify that, right? And when it comes to R, we have ngram package, ngram. What this does is this is going to look at the sequence of the words which were being written about, say, Maggie, sequence of words. And the moment it finds, or what it does is it's going to look into the n words, and using these n words, it is going to track n plus 1th word. And if the sentiment of all n words is positive and n plus 1th word is negative, that is when it's going to trigger an alarm for you. There's a subtle disturbance in the sequence of flow, so it's going to give a trigger. And you can use something called as hidden Markov, which is an unsupervised learning technique. And hidden Markov is used to actually try to identify these kind of discrepancies in the data. This is an unsupervised learning technique basically, and it's useful basically for identifying these kind of aberrations. It can also be used in your stock market. Say your stock index is going in a specific pattern and suddenly something goes wrong. So you'll be in a position to identify and take corrective action. In stock market, there'll be something called as circuit breakers. That is, if your stock market falls by greater than 10% or so, they're going to stop the trading for that specific day, or they're going to stop it for 2 hours following that sudden dip, so on and so forth, so as to ensure that um, a lot of money doesn't get wiped away from the market, right? That's circuit breaker. So all these things are possible, These are all the applications basically. And we can also look at text mapping, or sorry, trend mapping. This is also a form of your anomaly detection wherein the trend is going on in a specific way, suddenly the trend changes, so there should be a trigger that should be sent to us. And you can, of course, do social media analysis, you can scrape the web, you can crawl the web. There are a lot of web crawlers available. You have Google Web Crawler also, and you can extract the data and perform a lot of sentiment analysis. There is an algorithm called Alchemy algorithm, which also performs, sentiment mining. It's going to scrape the web. It's going to explain about the positivity and negativity of the data. And the interesting thing is it's going to provide the output of the file in JSON format, which can then be used for your further analysis. Right? These are all the possibilities basically when you deal with the data. This alchemy algorithm, I wish you explore this particular algorithm further. Alchemy algorithm. You have a lot of alchemy APIs which are available, right? You can use these APIs for natural language processing, machine learning algorithms, and it's used even in your deep learning algorithms now. Yeah. And API, I'm assuming you all know about that, application program interface. And you can also use hidden Markov, right? These are your unsupervised learning models. Uh, it's based on your simple Bayesian network, right? And then you'll be able to find out all the hidden things, right? Especially it is used in your pattern recognition when it comes to speech, when it comes to your handwriting, gestures that you show, parts of speech, musical scoring, so on and so forth. In all these scenarios, you can use hidden Markov, which is a different model altogether. You can probably explore hidden Markov also. All right. And now, this is the pattern that would follow. You need to first collect the data, or you need to do some kind of information retrieval. That is getting the data from social media, extracting the data from websites, all that is your IR, information retrieval. And then you need to perform some kind of cleansing normalization. We have done that using TM function in our text mining, right? We have tried to create a corpus, then we have tried to cleanse that by removing the white space, converting everything to a lowercase, removing the numerical characters, removing the special characters, stop words, so on and so forth. And then you extract the features. You can think about feature extraction as coming up with a document term matrix or a term document matrix. Yeah, that's your feature extraction basically. And then lexical analysis or entity analysis is your bag of words representation. If you have bag of words representation, then that's your lexical analysis. You can use that to mine the sentiments. And when it comes to entity analysis, it's you're going to assign label, and then we're going to do predictions on top of that. We're going to discuss about this part also. And of course, text analytics, so on and so forth. Using that, we're going to extract a lot of insights. You can also couple this with hypothesis testing to get better understanding. Yeah. So all this is possible. But for now, let us get started with latent directly allocation, LDA in short. This LDA was earlier developed by a professor. He's an assistant professor at Stanford, and his name is Andrew. This professor, along with a few friends of his called David and Michael, they have come up with this LDA concept way back in 2003. right? And this person serves as a chief data scientist in Baidu. Baidu is Google for China, right? We have Google for the world for search engine. We have Baidu in China for search engine, right? And he also spends a lot of time developing new algorithms. Very impressive person. Okay. Now, what is this LDA all about? It is a generative model, and it is a model for randomly generating observable data values. What are these observations now? Observations are words collected into documents. What is a document? A document is a mixture of small number of topics. What is this now? Each document, assume that I'm giving a speech, and in my speech probably I've used 100 sentences. Each sentence is a document, and that each document would contain mixture of small number of topics. So I might have made first statement about Indian politics, right? So that's a topic, underlying topic. Though I've used multiple words there, terms, those are the topics which are underlying within each document, that is each sentence of speech that I've given. And each word's presence is attributable to one of the document's topics. Say in the first sentence I spoke about Indian politics, in the second sentence I've spoken about Narendra Modi. And say in the first sentence I've told that Indian politics is a lot corrupt. Say that is a statement that I've made. And in the second sentence, I'm saying that Narendra Modi is doing a great deal to have cleaner India. So I'm speaking about politics, corruption. Here I'm speaking about Modi Prime Minister and taking some actions on having clean nation, right? So I'm speaking about different words here, but the words in this sentence and this sentence constitute to a topic called politics. So each word's presence is attributable to one of the document's topics. And each document may be viewed as a mixture of various topics. So probably in one sentence I've referred to multiple topics. Probably I'm speaking about women empowerment, and probably I'm speaking about corruption free nation. Two things I'm combining, right? So the specific document might have multiple topics in it. And we are going to use LDA to come up with those kind of topics. LDA can be used as a Bayesian model. Again, we are going to discuss about a technique called as naive Bayes later on. And naive Bayes is part of your data mining or machine learning, right? So when we discuss about that, this Bayesian concept will become very clear. Each item is modeled as a result of a mixture of underlying set of topics, right? So each word that you have will be modeled as a mixture of multiple topics. So this is how we are going to deal. So if I'm making a statement might mean multiple things in different contexts, right? If I say, wow, you're such a brilliant person, either I'm using it in true sense or I'm being sarcastic. So this sarcasm and using this particular statement in true sense, this is duplicated when it comes to LDA. It gives a provision to actually analyze that statement for true topic, for sarcastic topic, and then it'll determine to which topic that specific sentence has to be assigned to. So this is a very interesting topic. Let me show you all R code, and let us do this using R and try to understand what I'm trying to explain. We'll do that in a moment now. So we are just going to look at topic extraction using LDA. For that, we need this package called TM package. which is used for text mining, we need a package called SLAM, SLAM, that is sparse lightweight arrays and matrices, because we need to arrange the data into a matrix format, right? Document term matrix, which we have discussed as part of text mining. Yeah, we have to do that. And also there is a specific library called topic models. You need to install and load that. Now what I'm trying to do here is I'm trying to extract Narendra Modi's speech as part of the Independence Day, right, last year. And now I'm reading all the lines of that speech. We have the speech transcript available, right? That's in English language, so we are trying to analyze that. I'm assigning that to an object called X. So let me run this, right? So we have done this. Second step would be convert this into a corpus. What is a corpus? Collection of documents. What is a document? Each sentence is a document. So I've run that. Now, using tm underscore map, I'm trying to remove the punctuation marks. We are trying to, create a lot of stop words here. I mean, English language obviously has a few stop words. In addition to that, if you read the document, it could be some other medical transcripts document also, wherein the words won't be so straightforward. So you need to probably add a few other words by reading those initial few statements or sentences. Try to make sense on what are the stop words and try to add it to the existing stop word list. That will make your analysis much better. And I'm assigning it to an object called myStopWords, right? And now I'm trying to come up with, myData.corpus object by removing the words or removing the stop words. There we go. And we are removing the numbers because numbers might not make sense in this scenario, but there might be scenarios wherein numbers might be very useful. Maybe Narendra Modi is speaking about the GDP inflation rate in numbers. That might make sense, right? But for now, we are removing that. And we are coming up with the term document matrix. So let me repeat that. Your text mining tutorial is mandatory for you to understand this, because natural language processing is a step further to your text mining. So we are creating term document matrix, and I'm assigning it to this object. Now if I call this object, look at that. We have non-sparse and sparse entries. Non-sparse are the entries where you have some data available. Sparse entries are the entries where you do not have any data or you have all zeros. 97% of the entries are empty. That is what it says. Yeah. Now, if you look at the dimensions, this is term document matrix. So you have 1346 terms and 83 documents, because when we have read that we had 83 characters, 83 sentences. Now I'm forcibly converting that to a document term matrix. So earlier we had a term document matrix. Now we are converting that to document term matrix forcibly using this as dot. As dot function is forcibly converting a specific type to another type on this, and I'm assigning it to document term matrix. And I'm trying to count. When you look at the document term matrix, it appears in this way, right? You'll have a table like that. Right? Each document is a row there, and you'll have the terms such as maybe India, clean, corruption. All these could be our various words, terms. So what I'm doing is India probably in the first sentence was used once, in the second sentence it wasn't used, in the third sentence probably it was used 3 times, so on and so forth. I'm adding all these values for each and every word there. So we are using the apply function to do the summation of the row, one for row, two for column, right? So we're doing that and assigning it to row totals. And wherever you have row total greater than 0, you want to consider that, because if a word is not used even once, why do you want to, use it for your analysis? And I'm assigning it to dtm.new, and I'm applying LDA, latent directly allocation, on this, and I'm saying, hey, try to find out 10 topics. How do I determine that there have to be 10 topics, not more than that? How do we determine that? Right? For this, you can look into the scree plot or the elbow curve, WSS, within sum of square. We have looked at this, right? And try to look at how many topics are relevant, how many clusters, basically, right? So you can couple your clustering with this and try to get better insights. And based on that, you have to make a subjective guess on how many clusters will make sense. Maybe since Prime Minister of a nation is speaking about or giving a speech on the Independence Day, maybe he'll touch upon a wide variety of topics, which could be roughly around 10. So 10 is a safe bet here. That is how subjectively you need to include your domain knowledge, look at your scree plot, WSS plot, and then try to come up with a number of topics which are relevant. There we go. We have stored that in the object called LDA. So we have successfully run LDA now. Now, if you want to look at the terms in LDA, and say you want to look at the first 5 terms of all these topics, so you can just simply run this. Yeah. So when we look at the first 5 terms of each and every topic, this is all about, topic extraction. In a particular narration, how many concepts or how many topics did people speak about? That is this topics, right? We are only discussing about topic extraction as part of this tutorial. And look at this. If you look at topic 1, Narendra Modi is speaking about, probably that's the introductory part, all the people of the country, India, and probably he's in topic 2 referring about brothers, sisters, different festivals, national level, and we all can be together. Maybe that's the topic that he's speaking about. And probably in topic 3 is speaking about more of governance, less of government, because you remember when he was elected, in their manifesto it was clearly written that there will be minimum government and maximum governance, right? That could be one of these things. And there's a lot of emphasis on women empowerment, so that's probably topic 4. He wants to eradicate poverty, so that's topic 5 maybe he has spoken about. He is also referred to Mahatma Gandhi in an instance. And we also know about Swachh Bharat, so on and so forth. As part of that, he spoke about toilets, a lot of toilets being constructed in schools and in villages, so on and so forth, right? And villages upbringing, coming up with some kind of government model, so on and so forth. So that could be a topic. In that way, there could be multiple things, multiple topics that a specific person might have spoken about. Using LDA, we can extract all these kind of topics, right? And we can also extend this to probably 10 terms, which might give even better understanding, right? When we look at everything. So in that way, we can come up with topics. We can also plot that. So if you look at this, we can save all the terms in an object called tops, and we can come up with the names of the topics, topic 1, topic 2, that is a name given, right? And when we run this, unless I'm going to speak about that now, and we have stored it in TB. Now if I come up with a data frame matrix for this TB, here we go. So you have 10 topics, you have the words, right, and how many times those words were used, right? Now what we can do is we can come up with hierarchical clustering, and we can use a technique called ward.d2. Ward.d2 is a technique, you know, which is basically used to find out the distance between two records, two words, right? We have used Euclidean distance. Think about this as a form of Euclidean distance, right? The only difference is when you do y2 minus y1 whole square, we also take a square root of that, but here it is y2 minus y1 mod n square, right? Uh, in this way you calculate. That's the only difference, you know. There is also another thing called as ward.d, right, which is somewhat an older version, and then you have this ward.d2, right? Basically, you know, the key difference between ward.d and ward.d2, these are the two ways of calculating the distance. The key difference between these two is that when it comes to ward.d, you're going to calculate the distance based on squaring. You're going to square it to obtain this, right? And when you use ward.2, you're going to take, you're anyways going to calculate the distance, but you're going to square it. You're going to take a mod and then square it. So that's thin line of difference between ward and this. It's similar to your Euclidean distance only. You can think about that as being very similar to your Euclidean distance. Okay. Now this is a font basically. Hirakaku Proan -W3 is a font, right? So we want that font, and we are running hierarchical clustering now. There we go. And if I plot this, there we go. Now, the moment you look at this, you know for a fact that there are three different clusters. Topic 3 and 7 is more or less speaking about the same thing. Topic 1, 4, and 6 is speaking about, or Modi is speaking about similar kind of topic. And all these topics can be clubbed together. So if you look at this, topic 3 and 7, let me erase this. You have topic 3 and 7 because, yeah. Okay, we have topic 3 and 7. Topic 3 is about India can come, governance, world, country, move, goods, service, manufacturing. Topic 7 is also speaking about India, country, so on and so forth. So probably there are too many similarities between topic 3 and 6, hence they are combined together. Here also there's Modi speaking about independence, so on and so forth. Here in topic 6 is discussing about Mahatma Gandhi, togetherness, so on and so forth. And probably in topic 4 also is speaking about sisters, brothers. Here also it's sisters, brothers, so on and so forth. So maybe there are too many similarities between topic 1, topic 4, and topic 6. So in this way you can, you know, analyze a lot of speeches, speech transcripts, so on and so forth, and understand broad concepts which are spoken about. It can be applied to almost, I would say, all the industries, right? It depends completely on the context in which you're trying to analyze.